Welcome to today's episode. In the last episode, we were able to demonstrate some ways by which you can address the issue of missing data in your dataset. However, some datasets will require you to still create new variables or columns in order to facilitate proper analytical exploration. So today, we are going to be making use of a particular package in R called dplyr and also a muted function to demonstrate how you can do this.
This is where we stopped in episode 1 after we have addressed the issue of missing values. So for data, you can watch episode 1 video. So another set of data that you have is what we saved as seed data, and let us view the data to see how it looks like. If you look at the data, which are our seed data, so we have 1,498 staff members in that organization, and we're able to measure 17 variables. These are the variables, and we count it, you have 17. And all staff members, we have a total of 1,498 that we have here. So from this now, based on the salary, we want to classify whether the staff is a junior staff or senior staff. And any salary greater than equal to 30 will be senior staff, less than 30 will be junior staff. Like this one is a senior staff, this is a senior staff, this is a senior staff, this one is a junior staff, and so on and so forth. So how are we going to do that? I'm going to write a code to do that. Then also, you want to look at the weight and the height here. You want to determine the body mass index for all the staff members, and using the body mass index, we'll classify them to whether they are obese or not. Now, in a real life situations, we may have thousands of variables, in this area, and when you are analyzing or you are dealing with your data, you may not be able to handle all at a time. So we want to see how you can extract certain variables at a time as your analysis progresses. So let me write a code to classify whether a particular staff member is a junior staff or a senior staff. So quickly from our data here, our seed data that you're having, these are data. You want to create another column. So at the dollar sign, the 17 we have are this. We want to include level to know whether they are senior staff or junior staff. So I put level. So this assignment sign, and the function in R that will do that classification is if else function, but it will ask you that which data you want to use. And want to use DC data, that is the data you have here, we save here is what we use. I want to focus on the salary. So this dollar sign, you pick the salary, and the condition says that if the salary is greater than or equal to 30, comma, then that person will be senior staff, senior. Otherwise, will be junior staff, junior. So if you run this code, it automatically performs that function. So if you run this one now, I will say we run it. So let's view our data again and see what we're going to have there. Copy. I want to view it now. If you view it now, so let's go back there. So what we have now, level has been added. Our variable has changed to 18 instead of 17. So level has been added. See, senior, junior. If you look at this one, will be more than 30. It will be the second one is less than 30. Junior. If you check it here under the salary, that's why you have junior, and the first one is senior. So the add operation has been performed. So let's go back again and see how we want to determine the body mass index for those staff members. So we need a package for us to be able to calculate that. So we need to install that package first. So just say install dot packages, and the package you want to install is a dplyr package. Add a dplyr package. So because I have installed it, there's no need for me to install it again. So if your own case now, you can just run it. It's automatically installed. So let's turn it on to perform that task. Library, deploy. Now if you run this one now, it will turn that package on to perform the operation we want to perform. And what we want to do is we want to compute. So let's now get our another data now. So which is our seed data, and that case we want to compute. You can now see that our seed data now, the assignment sign, the function that will compute that is mutate. Now it asks you that which data do you want to use, and these are seed data. Our data here you see it as seed data, so that's what you are making use of. Then what exactly you want to compute? Body mass index, BMI, and is equal to, what's the formula? The formula for the body mass index is weight in kilogram divided by the square of the height in meter. So the weight now, here I'm using W because we use W as a variable name, capital W as a variable name. So GAT, that's the weight, then divided by the square of the height. So that will be height times the height, that's the square of the height. So this is the formula now for the body mass index. I said I'll put W here because if you come back to our data here, what I use here is W for the weight. For the weight here is W. If the small W, you are going to have small w, where I use a capital, so that I'll make this one to be capital here, otherwise we're going to have error. So let's run this code now. If you run this code, the operation has been performed. And if you view our data again, let's view our data again, sweet data, to see what we're having there. So if you view it again to see that data, I will run it, view. If you look at it for a while, see another color has been created, and this one has moved to 19 variables instead of 18. We started from 17. Then when you created levels, it's moved to 18. When you created another one, BMI, it increased to 17. So that's how to do that, and that's computed for everybody. For all 1,498 staff members, it has computed for that. So the next thing we want to do is what now classify this person, is it obese or not obese? This one, is it obese or not obese, based on the body mass index. So let's go back again and write another code that can help us to classify that. So from this our data, see data, then you want to create another column there by adding another variable. And what you want to do by adding another variable, these are those that you are having there. You want to add whether they're obese or not. That obesity. Now this assignment function that we're assigning to that, and the function in R that will classify is our if else function, comma, which data are we making use? It's the same thing, see data. Now for the see data, we want to concentrate on the body mass index for that classification. And if you look at it, you have body mass index there, BMI, for that classification. Medically, the rule is that if the body mass index is greater than or equal to 30, that person can be classified as to be an obese, otherwise not obese. So let's say 30. So if it's 30, it implies obese. So that will be obese, otherwise not obese. Yes, if you look at this code now, if you run this code, then you run this code, the operation has been performed. So let's view our data again and see whether the classification has been performed or not. So let's view our data. We run it. These are our data now. If you come here, we now have See, not obese, not obese, because all this one less than 30, which means everybody here, I think all of them, they are not obese. So obesity as a variable has been added. So this one has moved to 20 variables now, from 19 to 20 variables. Now, to understand this better, let's change our own rule by saying that if body mass index is greater than 2, is obese. Less than 2, greater or equal to 2 is obese. Less than 2 is not obese. So let's run it so that we're able to see clearly for obese and not obese. So let's view our data again. If you come back here and check it, so now you see not obese, not obese, obese. Because this is less than 2, this is less than 2. So you have not obese. This is greater than 2, greater than you have obese. So that's how we can now classify what you're having there to be obese and not obese. So at this level, that's you have to know how to calculate one or two things to be added to our table, because when you go to the field, there's no way you can measure whether somebody is obese or not obese. So, but from the weight, from the weight and height, you can determine that body mass index. From the body mass index, you can classify them to be whether they are obese or they are not obese. So let us assume that out of these 20 variables, you just want to work with a view of them. So how do you think we can extract that? So this function, this package will still help to do that, which is our dplyr package will still help to do that. So let us want to select certain variable from that, and we want to have another new set of data. So you can ask, okay, new data now, because you don't want to be carrying all those variables along. You just want to concentrate on those that we need. So the function in R that will do that is select. Select function will select from you. From where do you want to select? You want to select from our data, and our data is C data, comma. Now list those variables that I want to select. Let's say you want to select age, you want to select sex, I want to select salary, and that is all that I want to deal with, for instance. So if you run this one now, and let us view what you have in our new data. If you view this now, in our new data, let's view what you have there. See, it's only just age, sex, and salary for all of them. 1490. So all of that variable has been removed. So you can keep on working with this if you just want to deal with all these variables alone. So that is how you can select from the variable. Then also, for instance, from this data, if you want to select age, sex, salary, children, medical expenses, until gender and vol. So instead of listing all this one by one, you can say age, then to this. It will select this for you. So how are you going to do that? So you can just say new data, let me say new data 2, for instance. I want to save it as new data 2. So that's the assignment function, select. So from where do you want to select? From our data. Our data is C data, but what you want to select is age and so on and so forth. Instead of listing everything, you can just say age, because they follow each other, and vol. That's all. So if you run this code and you then view your this data 2 and see what you have there, when you view it, you run it and let us see what you have. So it has selected age to that level, and it cuts all of that one off. So instead of listing one by one, so you can do it in this way. So let's look at the data again. This is our raw data. You want to take from this one to this place. I want to take from let me say body width to obesity. So how you do that? You can come back to your code. You can say the same way you are doing it. Let me call it new data 3. New data 3. I want to save it as new data 3. Select. So from where do you want to select? From our C data. Then what do you want to select? You want to select from age to 4, then comma. You want to select from body width to obesity. If you run this one, it will go there and pick for you. So let us run it and see. Now let's view what we have in our data 3. Let's see what we have in our new data 3 view. What we have in our new data 3. You view this one. So you can see from age to VO, then from body width to the last one, obesity. So if you have millions of variables, so that is how you can play around it to pick anyone you want to work with at a particular time. So, and it will make your analysis move on smoothly. I think you have also gained one or two things from this episode 2, and we are going to continue from this place in the next episode.